Welcome back. We are now on to the second section of our flipbook on polynomials. We are in the standard form and classifying polynomials section. And we're going to be talking about how to get things into standard form, to practice that a little bit. And then we're going to talk about classifying polynomials. To be able to classify polynomials just helps us like grow in our proficiency of them and talk about what they are and what they mean. And when you're proficient in words and phrases like we're going to be talking about, it just helps us be more proficient mathematicians. So this section hopefully you will find pretty easy once you have gone through it. Again, it's going to feel like a foreign language because it is to you. It's stuff, words you've never heard before. But hopefully it comes pretty quickly. If you take that systematic approach that I'm going to show you, we will get there. So, writing things in standard form, I hope that that's the easy part for you. We're just looking at what is the highest degree. Since these are all y's, that makes this really, really easy to write in standard form because we don't need to add coefficients within a term. We can just look, hey, here's a 4, here's a 3, here's a 2, here's a 1. So those are the degrees of each of these monomials contained inside this polynomial. So we just need to put them in order from greatest to least. So here's our highest degree. So we're going to write 3y to the 4th plus 2y to the 3rd minus y squared plus 7y. Now, a couple things that I want you to understand about how we got this in this form. First, we remember from first semester, we talked about this, is that now we always think about any sign out in front of a term as giving that term its positive or negative value. So we brought this subtraction sign with this y squared because it belongs to the y squared. It belongs to the term that follows it. In the same way, since there was no sign out in front of this 4y, we knew it was a positive term, and so we would write a plus 7y when writing this now in standard form. The second thing I want you to realize is, like, why can we do this? It's because anytime we are adding or subtracting things, we can write it in any order we want to because it does not matter what order we do things in. For instance, 1 plus 2 plus 3 is exactly the same as 3 plus 2 plus 1. The order does not matter just as long as we do not change the value of each of the terms within the polynomial. Okay. So another example, we're looking at terms. Here's the highest term. Even though it's negative, that doesn't matter. We are only looking at what its degree is. This is a third degree monomial, so it gets to go first. This negative sign goes with it. And then I see a second degree monomial, so I'm going to say plus 3m squared. Notice that there's no sign out here, so I consider it to be a positive term. Then I've got a first degree monomial, so I'm subtracting 2m. Finally, I've got plus 7. So we can see that we've got 4 terms. We started with 4 terms. We got 4 terms. We're good. So now you try, okay? Now that you've paused the video and try, let's kind of move on. We are going to talk about classifying our polynomials. And every time we classify a polynomial, we need to say 2 things about it. First, we need to say what its degree is. Second thing we need to say is the number of terms that are within the polynomial. And given the number of terms, we're going to give it a few different special names that are going to go with it. So just like in chemistry that we say hydrogen peroxide, that tell me what this thing is made up of. It's made up of hydrogen and oxygen, and that peroxide tells us how many hydrogens and oxygens we have in this molecule. In the same way, when we have a polynomial, I want to be able to give it a single name that contains two components that tells me everything about this polynomial without even looking at it. So if it's degree 0, I hope you've seen, here's a degree 0. That is just a constant or a number. And so we're just going to say that, a constant. If it's a degree 0 polynomial, that means that the only thing we have is just a simple number there. And we call that a constant. If it's degree 1, that means we've got 2x plus 3. We all know that that is linear. We've spent months and months and months with things that are linear. A degree 2 is something that I've talked to you a lot about, but we haven't played with yet. It's called something that is quadratic. And we all know, I think, that this is going to make a parabola. Something that goes like this. We've got something that has x squared in it, and that's our highest degree. If it's highest degree, if it's a degree 3 polynomial, we are going to call it cubic. That is also going to make a graph that we're going to get really used to over the next couple months. 4, and these are starting to get to words that we don't use very often, but it's called quartic. Degree 5, we call it quintic. And I never use 4 or 5, but definitely not something 6 or more. When we get to that, we're just calling it by its degree. We're going to call it 6th degree and so on. So if it's a 7th degree, we're just going to call it 7th degree, 8th degree, etc. Okay. And now, so this is the first word when we are defining or classifying any polynomial. The second word we're going to use describes the number of terms that is contained within this polynomial. The first thing, the degree, gives it its shape, gives it its feel. The highest degree on that polynomial kind of controls what our graph is going to look like if this is something we're going to graph. It controls the data set. So that's why we care so much about the degree. But we want to say also how many terms it has in it, how many kind of influencers there are on this polynomial. So we're going to start with one term. We already know that this is a monomial. And we know what a monomial looks like from our first few pages here. A degree are 2 terms. We're going to call that a binomial. Obviously, the word bi means 2. No shock here. 3 terms, we're going to call it a trinomial. Trinomial. And if there are 4 more terms, we quit giving it these prefixes, and we are just going to say that it is a polynomial, or it has many terms. Okay, now that we have these definitions, we are going to go to the next page and try our hand at this. So, rewrite into standard form, then classify by degree and number of terms. Okay, so first job is to write it in standard form. I see that this is a degree 3, so I'm going to write that first. Negative x to the third minus 4x squared plus x, this is positive, and finally a positive 7 finishes off our polynomial here. Okay. So the first thing we're looking for is, I'm going back to this chart. Let me see if I can get both of these things on my screen. Okay, I'm going to look at this chart first. And I see that its highest degree is a degree 3. So I'm looking here, and I see that that's called cubic. So I'm going to write, this is a cubic. Cubic what? Well, it looks like there's 1, 2, 3, 4 terms, anything that has 4 or more, we're just going to call it a polynomial. Okay, so grab a word from this category and grab a word from this category. Okay, a cubic polynomial. Let's do this second one. I've got my highest degree is right here, negative m3 plus 3m squared plus 2. Okay, so we want to say what degree that this polynomial is. It's, again, a degree 3, so we're going to call it cubic. And then we need to see how many terms does it have. 1, 2, and 3. We could call this a polynomial, but we're going to be even more specific. We're going to call it a trinomial. A cubic trinomial. Okay, number 3. We need to write it in standard form first. So I've got 11k to the 4th. We're just looking at these exponents plus 6k squared minus our 8. Okay, so we're looking at the degree here. This is a 4th degree. So I'm looking here, and we are going to call this very specifically a quartic. A quartic what? Well, I've got 1, 2, 3 terms. 3 terms, that's a trinomial. So I'm calling it a trinomial. Okay, so just a few more real quick. We are going to, let's just do one more row together, and then I'm going to let you do the last 2 rows on your own. This one's easy. No degree, no variable. It is a degree 0, so we're going to call it just a constant. This is just a number. Next one, we need to get into standard form first. So this is 7p minus 4. I hope you already are like, ooh, I know what that graph looks like. This is linear, a degree 1, a linear 1, 2 terms. This is a linear binomial. And most things that are linear are binomials, right? Because we can't have thrown in a squared or a cubed here, which would have made it non-linear, right? And so if we're going to put them in order, 1st degree, 0 degree, I can't have a negative degree here. So this is a linear binomial. Okay, and the last one here, I'm looking for my highest degree. That's this 5th degree here. So I've got 3j to the 5th plus 8j to the 4th minus 9j squared minus 2j. We said this was a 5th degree. So I'm looking down here. This is quintic. Q-U-I-N-T-I-C. It's a quintic what? Well, there's 1, 2, 3, 4 terms. We said anything 4 or more, we're just going to call a polynomial. Even though all of these things are polynomials, since the word poly means many, we're just going to say if it gets up there, we'll just call it a polynomial. So your task to finish this section off then is to finish the rest of these problems and just really make sure you understand all of this before you walk in the door tomorrow. You know where to find me if you have any questions. Good luck.